chemistry quiz. You're going to print out your chemistry primer. You're going to answer the questions in it as you go through chapter 2 of your textbook. Then you have the answers in the primer printed out when you go to take your quiz, because that's where the questions are going to come from. And we left off at
RNA.
right, RNA. So what are the bases in RNA?
Cytosine, guanine, suction, and uracil, and then
Right, A, C, U, and G. DNA, A, C, T, and G. So you have thymine. Thymine is one of the bases in DNA, on the nucleotides that make up DNA. RNA does not have thymine. It has uracil instead. So the bases are A, C, T, and G when you're in DNA. When you go to RNA, replace the T with the U, uracil.
Are they going to be in the shortcuts, like on the, just the letters?
No, it'll be the full name.
The full name, okay.
Remember, if I clean my microscope. Alrighty. What is the plasma membrane and the membranes of eukaryotic organelles made up of? What kind of organic molecule? Right, phospholipids. Remember, plasma membrane? Membrane is phospholipid bilayer with proteins interspersed. Good. Alrighty. Okay. If you put a bunch of amino acids together, what do you get? A protein, right. And the protein could be an enzyme, but you get a protein. So amino acids are the building blocks. We call those monomers. Mono, one mer unit. The protein, which is many monomers that are linked together through a, what kind of reaction links monomers together? Dehydration synthesis, good. That would be a polymer. So your big molecules like proteins, DNA and RNA, complex carbohydrates, those are polymers, big molecules consisting of many, many, many monomer units. If you put monomers together to make a polymer, you have to do a dehydration synthesis. If you want to break a polymer down to monomers, you have to do hydrolysis. Okay, and okay, what is the monomer of DNA? People always forget this one. Nucleotide, good. And nucleotides have the bases on them. And the bases are called purines and pyrimidines, otherwise known as A, C, T, G, and U. Okay. All right, so DNA is composed of nucleotides. What did we say proteins are composed of? Amino acids, good. So nucleic acids are composed of nucleotides, and proteins are composed of amino acids. So don't let that acid word throw you off. Because in the case of nucleic acids, RNA and DNA, that's what the NA stands for, nucleic acid, those are the polymers, the big molecules. But when it comes to protein, amino acid, the acid word, amino, that's the monomer, not the polymer. So don't let that acid word throw you off. Alrighty. What if I take a whole bunch of simple sugars, monosaccharides, and put them together? Then what's the big molecule called? Polysaccharide. Good. Alrighty. What kind of a molecule is ATP? Is it a fat?
No.
Is it a carbohydrate?
Isn't it like
Is it a protein? It's a nucleotide. It's in the nucleic acid family. ATP is a nucleotide. And nucleotides are monomers of nucleic acids. ATP is a modified nucleotide, but it's a nucleotide. We'll go over a lot of this when we do that in class, but, okay. Okie dokie. Okay, let's put our monomers together. Glucose plus glucose equals what? Maltose. Did you ever have Malta? Does anybody know what Malta is? Anybody Hispanic?
I know what
You know what it is? Are you Hispanic?
it is. Yeah.
Really? Your name does not sound Spanish at all.
My dad's Indian.
Okay. So tell us about Malta. Have you had Malta?
It's a fermented drink.
A fermented sugar drink. So it's kind of like beer, but it's sweet. It's really sweet. And boy, that stuff kicks butt. You think Red Bull gets you going? That Malta does better than Red Bull. So in the 1980s, early 1980s, I was a pharmaceutical sales rep in Queens, New York. And in Queens, they have like a Korean neighborhood and a Spanish neighborhood and, you know, all these different neighborhoods. In that Spanish neighborhood, those people were so nice to me. Oh, they loved me. And sometimes the doctors would say, come on in and go in the back, because a lot of them had their practice like in a house, and they'd sit down and have a Malta. Because it was a long, hot day, and I'd start running out of energy. They'd be, here, have a nice cold Malta. Oh boy, you drink that thing and you're buzzing around for the rest of the day. So it's like sweet beer. But Malta always reminded me, glucose plus glucose is maltose. Malt sugar is the sweetest sugar there is. Why? Because it's glucose plus glucose. So Malta is really sweet. And kick ass, by the way. Love that stuff. Probably got a lot of calories, however. What if you put fructose and glucose together? What do you get? Sucrose, which is table sugar. And what if you put glucose and galactose together? You get lactose, which is milk sugar. Milk contains sugar. You look on your milk bottle and look at the sugars content, and you'll see lactose is milk sugar. Milk actually contains sugars. Okay, so you know how to make your disaccharides from your monosaccharides. And what kind of a reaction would you do to make a disaccharide out of two monosaccharides? What kind of reaction is that when you put two monosaccharides together? Dehydration synthesis. Good. What if you break apart your disaccharide into two monosaccharides? You have to do what kind of a reaction? Hydrolysis. Good. Okay. Whenever you see, I want to say adonitol. What is that? Sorbitol, mannitol, adonitol, glycerol. Do you ever look at your sugar-free gum? Sugar-free gum has sugar alcohols in it. Mannitol, sorbitol. When it's got the ol ending, it's a sugar alcohol. And they'll call that sugar-free. So it's sugar-free gum. It's not really sugar-free. It just has sugar alcohols in it. Glycerol is a sugar alcohol. It's the backbone of triglycerides. So you have 3 carbons. Your glycerol is a 3-carbon sugar alcohol. And then each carbon has fatty acid chains coming off of it. So you have glycerol in fats. That's the backbone of those fatty acid chains, is the glycerol molecule. So when it comes to DNA, the monomers are nucleotides. Proteins, the monomers are amino acids. Carbohydrates, the monomers are monosaccharides. When it comes to fats, the monomers are glycerol and fatty acid chains. Has 2 different kind of monomers. And okay. Nucleic acids contain carbon, hydrogen, and oxygen, but they also contain phosphates and nitrogens. Proteins, same thing. They contain nitrogens. When you're looking at lipids, it's got carbons and hydrogens and sometimes oxygens. But when you look at carbohydrates, you always see a repetitious pattern of CH2O. So you're always going to have 1 carbon, 2 hydrogens, and an oxygen. That's what carbohydrates are made up of. Amino acids, remember, they have a central carbon, that's called the alpha carbon. On one end, they have an amino end, that's their nitrogen-containing groups. On the other end, they have carboxylic acid, and then they have a functional group, R, sticking down. So when they call it an amino acid, amino means it has NH2. Acid means it has carboxylic acid, COOH. Okay? That's why they call it an amino acid. Okay, we did that one. And then you have actually it's a common sense question, but do you know what dextrose is? Does anybody work in healthcare now? And you hang a bag for your patient's IV, he's going to be fed artificially. So what are they going to give him? Something the body absorbs easily. They're going to give him sugar. They're going to give him glucose. But when you hang the bag, does the bag say glucose? It says dextrose. Dextrose is the same thing as glucose. Okay? When you're in the hospital, they're probably going to call it dextrose. They're probably not going to call it glucose. Okay. Write myself a note. Okay, we reviewed all the chemistry questions I have for you. Let's talk about staining. Now, some of the staining questions you don't know yet because we didn't do the gram stain. So I'll give you a heads up when that's the case. Okay. Direct stains are what kind of a stain? Is it a differential stain? No.
Simple.
Simple, yeah.
Simple stain, right. Okay. Why is it a simple stain?
Because you only use one dye.
Right, because you only use one stain. And what kind of a stain or dye are you going to use? What kind of charge? Basic, good. Okay? When you do a direct stain, why do you heat fix the bacteria on the slide? Why do you heat fix? Easy answer.
Make sure they aren't removed once you.
Yeah, it sticks them to the slide. So when you heat fix, you literally melt the cells a little bit, makes them stick to the slide. Because in a direct stain, you want to stain the cells directly and rinse away the excess stain. When you rinse away the excess stain, you don't want to wash your bacteria off. So that's why you have to heat fix for a direct stain, because there's rinsing involved and you don't want to lose your bacteria. You want to stick them to the slide. When you do a negative stain, you're going to add what kind of a stain? An acidic stain. And you're going to add that to the slide and mix your bacteria into it. And what color are the bacteria going to come out? Good answer. They're not going to come out of color. They're going to be clear. So when you use a negative stain, your bacteria are going to be clear. It's the slide that you're staining. You're staining the background. So now think about a capsule stain. Remember you saw your little cell was stained purple. Then you had a clear area where the capsule was,
White.
because the capsule repelled the stain, right? It was white or clear. And then your background was stained. A capsule stain is actually a type of a negative stain because the capsule repels the stain and comes out clear. And the whole background is stained. Okay, in a negative stain, you don't heat fix. Why? Why not?
Distortion,
What?
so you don't distort it.
Okay. Because you don't heat fix, you're not going to distort the shape of your cells as much because you're not melting them. But why don't you heat fix when you're doing a negative stain?
Because
They'll
it could
fall off.
damage the bacteria and whatever.
No, because you're not going to rinse. In a negative stain, you're not going to rinse. You're going to put the stain on the slide, mix your bacteria into it,